this example problem, we are given that when a proton is moving vertically upward, the proton feels a force point pushing it to the west. When the proton is moving due north, the proton feels a force of 0. Now, what I did was I drew a map of a state. I have my north, south, east, west directions. And if you imagine that you are looking down onto your paper and you see a state in this position, then above the paper would be the vertically upward direction, behind the paper would be the downward direction. So in addition to north, south, east, west, I drew the circle with the dot in it to signify upward, the circle with the X in it to signify the downward direction. So what direction does the magnetic field in this region where the proton is moving point? So what I'm going to do first is, if I notice that if proton is moving northward, the proton will feel no force. Now by moving north, that means you're moving north, but you're moving at constant altitude. So you're always moving to the north, but you're not changing your height in any manner. So what is the strength of the magnetic force? Well, the strength of the magnetic force on a proton is given by QVB sine theta. So when is the magnetic force ever going to be 0? Well, the magnetic force will be 0. Okay, the charge of the proton, that's never going to change. The proton is moving, so V will be something greater than 0. There is a magnetic field in that region, so B cannot be 0. The only possible way for the magnetic force to be 0 is when sine of theta is equal to 0. So we ask ourselves, at what angle will sine of theta equal 0? And the sine of theta is equal to 0 for two possibilities. The angle is 0 or the angle is 180 degrees. Any other angle, the sine of theta is going to be non-zero and we'll get a non-zero force. So this angle is the angle between the direction of motion and the direction of the magnetic field. So if the particle is moving north, theta equals 0 implies the magnetic field points north. If the particle is moving north, theta of 180 would imply you're moving opposite north or south. So theta equals 0 would be for the magnetic field points north. And theta of 180 would mean the magnetic field points south. So from an infinite number of possible directions, we right away narrowed it down to 2 possible directions for the magnetic field. Now what we're going to do is we're going to use the first piece of information. We will assume the proton is moving upward. Upward is out of the board. And then I will curl my 4 fingers in the direction of the magnetic field. And I know that I want my thumb to be pointing to the west. A proton is a positive charge, so in this case the force on the proton should be in the same direction as my thumb. So if the proton is moving vertically upward or out of the board, that would be my forearm. My 4 fingers, I'll try south first. My thumb is raised and it is pointing to the east. I do not want my thumb pointing to the east, so this possibility is going to be wrong. So right away, we could probably infer that the magnetic field will be pointing to the north. Just to be thorough, we could check it. So if my proton is moving vertically upward out of the board, I curl my 4 fingers to the north towards the top of the board based on how I drew this picture. When I raise my thumb is pointing to the west, and that's what we want. Moving vertically upward out of the board, magnetic field points north. The force is to the west. So we found that the magnetic field in this region is pointing due north. The rest of this problem is going to be determining the strength of the magnetic field in this region. So for the strength of this magnetic field, we won't be able to really get any useful information from this piece from here because it doesn't matter what values these are, we multiply by 0. But we will be able to use this piece of information fairly nicely. So if I say F is equal to QVB sine theta, okay, we are told that the force on the proton is 8 times 10 to the negative 14 newtons. The charge of the proton is 1.6 times 10 to the minus 19 coulomb. The speed of the proton was given in the problem as 5 times 10 to the 6 meters per second. We do not know the strength of the magnetic field, so I'll leave that as B. And the sine of the angle represents the angle between the direction of V and the direction of B. So the angle between the direction of motion and the direction of magnetic field. We are told the proton moves vertically upward, so that's out of the board. The magnetic field points to the north, and so those two directions are perpendicular to each other. So that would then be times the sine of 90 degrees. Now the sine of 90 degrees is just equal to 1. And if I send these numbers through a calculator, I find the strength of the magnetic field in this region is going to be 0.1 Tesla. So if I want to write out a full vector as my answer, I could write the magnetic field is 0.1 Tesla to the north.